Hello class, this is Mrs. Albritton of Albritton's Math Class, AMC. Today we're going to take a look at the study guide for our radical functions quiz that's coming up next week. So let's start with number 1. Now what I've done is I've actually put a split screen on my board so that you can see the study guide and the Desmos calculator, because a lot of these problems can be completed by graphing the actual function. So number 1, describe the end behavior of f of x is equal to the square root of 1 minus x. And for this particular problem, we see that there's a slight mistake. This is actually will be changed to 3 minus x. And if you look over at the Desmos calculator, notice that I've already graphed it. So I typed it in, y equals equal to the square root of 3 minus x, and this is the graph. So I'm gonna go ahead, let me close up this pane here so that we can see the graph a little bit better. So let's see if we can identify which one of these multiple choice answers is correct. And when they say describe end behavior, we're talking about how does the graph behave at the end or as it's ending. And in this case, the graph won't end, but what's going on as it starts at this point and goes on forever. So the first thing we want to do is, since these radical functions do have a starting point, let's go ahead and identify that starting point, which is right here. This is 3, 0. So let's see what our choices say. A, the way you read this is as x approaches negative infinity, so as the x values get smaller, that means they're coming this way. The y value, remember f of x is just another way of saying y, it's the function notation for y. It says that the y value gets bigger, positive infinity gets bigger. And we can verify that. We can actually look at some of these points. For example, here's this first point. Let's take a look at, here's another decent looking point because it's right at an intersection. So this is over 2 up 1, 2 comma 1. Here's another good point that we can look at, negative 1 comma 2. And let's find one more decent point. Here's a point. So this is at negative 6, 1, 2, 3. So let's take a look here. Again, this reads as x approaches negative infinity. That means as the x coordinate gets smaller, 3, 2, negative 1, negative 6, the y coordinate gets bigger. Let's check it, 0, 1, 2, 3. And that's true. So this part of this choice is correct. Let's check the next one though, because it has a second part. This says as x approaches negative 3, f of x approaches negative 2. So what we're doing is looking for this point, negative 3 comma negative 2. Let's check it out. So if I start at the center and I count negative 1, 2, 3 and go down negative 2, it says 1, 2. So this point. Well, this is not possible because the graph, which is the red line that you see, does not touch that point. So A cannot work because both parts have to be true. B reads as x approaches 3, f of x approaches 0. Okay, so when x is 3 is y 0. Yes, that point is actually on the graph. So that part is true. Let's check the next one. As x approaches positive infinity, that means as the x values get bigger going this way. So here we start at 3 as it goes 4, 5, 6, 7. Is f of x or the y coordinates approaching positive infinity? So are the y values getting bigger? Well, that's not possible because the largest x value we have is 3. There is no 4 comma something. There's no 5 comma something because it begins at 3. So it's not getting any bigger than 3. That means these points, these values of x greater than 3 will be undefined. So that won't work. The first part worked, the second one didn't. Let's check C. Now notice that C, that first part, as x approaches negative infinity, y approaches positive infinity, matches this that we determined was correct or is valid on that graph. So let's check the second part. As x approaches 3, y approaches 0. And that is true because we have the point 3 comma 0. So C is the correct answer. All right, let's take a look at problem number 2. Graph each function, state the domain and range. Well, again, I've already pulled up the function. I've graphed it in Desmos, and this is how it looks. Let me close this pane so that we can get a better look at the graph itself. And let's go ahead and match them up. And it looks like we can pretty much use process of elimination here. So I've graphed this radical function and we're just matching up the graph pretty much. Yeah, it asks for domain and range, but in this case, none of the graphs are so similar that we need to be pay a lot of attention to domain and range in this case. And the first thing that I noticed, and you probably noticed it too, is look at D. This is not even a radical graph. What kind is it? Straight line? This is a linear function. So that one, of course, won't work. And then when I look at this one, I see that the starting point is down here in quadrant 4, and then it goes towards the negative infinity for x, and it's gonna go positive for y. So that won't work. It doesn't even look like that one, does it? It's going in the wrong direction. Okay, this one, this starting point is at negative 3, 0. And I don't think that's at negative 3, 0. This is at, let's see, we're over negative 7 and we're down negative 4. Same here. So here we're over negative 7, down negative 4. Obviously this is the matching graph. So B is correct for this one. Okay, let's take a look at number 3. Problem number 3 is similar to number 2. Again, we're just asked to graph this function and then determine which one is the matching graph, domain, and range. So again, we can sort of eliminate some that don't match the graph. So I've already graphed y is equal to 2 times the square root of x plus 2. I'll close the pane to get a better look at the graph, and let's just match them up. And clearly I can see that it doesn't match. See, B doesn't match, it's not even going in the right direction. C doesn't, neither does D, so looks like A is the answer. Let's look at this starting point, that's negative 2, 0, and this starting point here is also negative 2, 0. And they match, they look alike. So A is your answer here. Problem number 4. So here we're getting into the solving radical functions section of the study guide. So for number 4, we're asked to solve the equation of the cube root of D plus 2 is equal to 7. Now we actually started this lesson on solving radical functions talking about how do you solve equations that we've done in the past. For example, if I had an addition equation, how would I solve it? The inverse of addition is subtraction. A division problem or division equation is solved by using its inverse, which is multiplication. This problem happens to be a cube root problem, and the cube root, its inverse is to the 3rd power. All right, so the way we're going to do this is we're going to apply the inverse operation. I'm going to rewrite it here so we'll have some space. So the cube root of D plus 2 is equal to 7. And don't forget that the bottom line for solving any equation, inequality, anything, is to get the variable isolated. So we want to get the variable by itself, which means D should be all alone. It should be isolated. Right now it has a cube root, it has a 2. So let's go ahead and start solving it. The inverse of cube root is cubed. And this is what I mean. If I want to get rid of a cube root, then I will cube, or actually write that problem to the 3rd power. But keep in mind that when you're solving any equation, whatever you do to one side, so whatever I do to the left side of the equal sign, I must do to the right side of that equal sign. And since I've cubed this left side, I gotta cube the right. Now what that does, which is good news for us, is a cube and a cube root cancel each other out. And that leaves just the radicand D plus 2 by itself. So we've gotten rid of the radical. The cube root is gone. And then when I do 7 to the 3rd power, well, that means 7 times 7 times 7. So 7 times 7 is 49, and 49 times 7 would be 343. Now let's go ahead and solve it because it's just a one-step addition equation now. So how do I solve D plus 2? Since it's an addition, I do the inverse of addition, which is subtraction. And why do I subtract the 2 and not the 343? Because we want the variable by itself. And the 343 is not over there with the variable. The 2 is. That's why we want to eliminate that one. Okay, this cancels. Here's my variable. isolated on one side of the equal sign, so it's the only thing on the left-hand side, and when I subtract this, I get 341. So here's our answer for that one. Let's do this one here. So I'm gonna slide this up just a little bit so we can see it a little bit better. Alright, so I'm gonna look at number 5, 6, and 7. Number 5, we've got 6 plus another cube root of cube minus 4 equals 9. All right, let's write. I'm gonna write this out just a little bit bigger so we can see it. Cube minus 4 equals 9. So now the first thing that I need to do is, since I've got a constant isolated by itself, let's go ahead and eliminate that one first. How do I do that? Since it's a positive 6, I do a minus 6 on both sides. So now it's no longer here, but I still have my cube root of q minus 4. And here, instead of 9, I got 9 minus 6, which is 3. Remember, how do we eliminate a cube root? We do it to the third power, or cube it. So I'm going to do the cube root of q minus 4 to the third power. Whatever I do to one side of the equal sign, I have to do on the other. Now this essentially cancels out the radical, which is good. We don't have to deal with that radical sign anymore. And then 3 cubed is 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. And now it's just a one-step subtraction equation. How do we eliminate subtraction? We use addition. So a little plus 4 on both sides. And in this case, q is equal to 20, oh, in this case it'll be 31. So D is our answer for that one. Okay, let's look at number 6. Same thing we're solving. Let's write this one out. Now this one says instead of cube root, since I don't see a number here in the index, that means 2, square root. So this is the square root of x minus 9 plus 1. Notice the plus 1 is not up underneath the radical with the x minus 9. And that makes a difference. So the first thing we want to do is get rid of that constant that's alone. So I'll subtract 1 from both sides. Bring what's left down. So I've still got the square root of x minus 9, but this is no longer there. And here we've got 6. Now remember, the way we eliminated a cube root is we did that radical to the third power. The way you eliminate a square root is you do that radical to the second power. And it looks like this. So I've got x minus 9, I'm gonna square it. Whatever I do to one side, I've gotta do to the other. So a square root and a squared cancel each other out. Just the radicand. Radicand is whatever is underneath the radical sign is left. 6 squared is 36. When I add 9 to both sides, x is equal to 45. So B is the answer for that.